Professor Blackman contributed to the theoretical aspects of electron diffraction and to the understanding of how material of one kind can settle on and grow upon the surface of a crystal of another kind. The first successful experiments in transmission electron diffraction were done by G.P. Thomson, now Sir George, the son of the discoverer of the electron, J.J. Thomson. He directed a beam of high-velocity electrons through a very thin gold foil. The foil was composed of millions of very small crystals randomly oriented, so that some were tilted at the appropriate angle to diffract electrons. This diffraction contributed numerous spots in an overall pattern on a photographic plate. A South African research student, Moses Blackman, became closely associated with the work of G.P. Thomson.
I went to England actually in 1933 as a Beit scholar to the Imperial College, and there I actually continued my work on, I started at Göttingen on lattice dynamics, worked on heat properties of crystals, particularly heat capacity of crystals. At that time, I was in the mathematics department as a research student. G.P. Thomson was working in the physics department as head of the department, and he, of course, was the great expert on electron diffraction. Professor Thomson, that's George now, is really one of the old school of professors. And I think in those days the only figure that really counted in the department was the chief. Everybody else was really a cog in the wheel. As I spent another 2 years at Cambridge doing research, again on crystal physics. Then I came back to join him as a theoretical assistant, and I was with him until he retired some 10, 12 years ago. Well, when I came to the college as assistant lecturer, and really as his theoretical assistant, he was at that time writing a textbook on electron diffraction, a theory of practice of electron diffraction, Thomson-Cochrane. Writing that textbook had raised a number of theoretical questions, and in particular he asked me to look into a relatively new theory of the diffraction of electrons due to beta, so-called what's now known as the dynamical theory. Well, I worked out some of the implications really for his textbook originally, and so I had a fair background of the theory. And when some papers, experimental papers, appeared, which suggested that the simple theory of electron diffraction wasn't quite correct, I was really in a position to rough out what is now called the two-beam theory in something like a week or two. I had all the background formulae anyway. And this really led me into what is now called the dynamical theory. It's a subject I've retained my interest in ever since. I did this actually in 1938. I suppose no scientific work lives forever, or at least only the very greatest achievements do. I think if in the course of time, I think all work disappears into a general body of knowledge and ceases to be mentioned even in textbooks. But if the consequences of that work are still used for what I'll call a reasonable lifespan, say 25 to 50 years, I think that's all one can ask.